Unmute me. Admitting all. Admit all. There we go. Seven, not bad. There we go. Okay. How's it going, everybody? Can you hear me okay? I'm going to give this I'm going to give this a try. I've got a little bit of a voice, so we'll see how this goes. Thanks for coming. I appreciate it. Sorry for the absence over the last week. It was unavoidable, unfortunately. It's just now a couple minutes after 2, so I'll give it a moment or two for any stragglers, but I think this is probably all we're gonna gather today, it looks like. Is that a question already?
Yeah.
Go ahead.
So I had so with the last 2 things that were due on this past Sunday with the video lectures, like I didn't watch those video lectures because I was like waiting for Tuesday and Thursday. So should we just do those and then just turn those in?
Yeah, just do that. I think that's best.
Okay.
And I'm gonna be a little lenient about some of the the due dates from the first couple of weeks, just because it was so kind of touch and go with my personal health and everything and the schedule and all that. So just do your best to get those looked at, get it, get the little responses done so that, all that's on.
Okay. Yeah, okay.
All righty. Okay. So we could probably get started. So let me go ahead and share my desktop here with you guys. All right, what I'd like to do is just sort of start I want to open the conversation today just with, uh, the basic question to you guys, which is how is the content working out for you, given that we went totally online here for for a week without any live sessions? Are you able to follow along with the content okay in web courses? Is anybody having any difficulty in any way with the course, given the way it's laid out and so forth? You guys are okay so far? Okay, I got 1 thumbs up, so that looks good. Okay, so so last week, I really wanted to have the live session with you guys about the digital media part of the discussion. I felt like, the cinema camera survey section was kind of easy enough for you guys to sort of plow through on your own. Same with I mean, we covered a lot of this kind of in the first week, so it wasn't so bad. But I thought maybe I would just take a look at some of this material from 1.4 real quick before I talk to you about lenses, if that's cool. Or did you guys get the gist of this section? Did you really kind of understand what was being looked at there? Anybody have any questions from 1.4, the digital media section? None? You guys are all doing pretty good with the content, the way it's set up then? Okay, I got a thumbs up. That's cool. Okay. I'm never quite sure. Sometimes classes, I talk about the digital media portion of the material, and it seems like I lose a lot of people. And then some people seem okay with it. They seem to understand, totally the idea of, your recording media and how to figure out how much time you have and so forth. Um, if you want me to spend some time on that, let me know. Otherwise, we can sort of talk about lenses today. That would be fine as well. Um, the whole point of that section was to get you to understand how your camera is creating image files. Yes, Amanda, go ahead.
Yeah, so I know our exam is literally next Tuesday, so I was just wondering what's the best way for, I guess, studying, because I'm not sure if I'll be able to make it to class on Thursday in terms of like, do we watch the entire like 4 hour lecture or what do we do? Do you recommend?
For your, don't think of it as an exam. It's really not that big of a deal. It's going to be a quiz on the first 7 sections of the class, so up to filters, which I'll talk to you about on Thursday. There is a review video. So if you watch that, I think that's probably going to help a great deal. You can go back through and look at the PDFs from each of these video lectures if you like. The quiz is only, I think, 30 basic questions. So it's not really that, doesn't dive that deep into a lot of things. It's just a cursory view of what we've looked at in the first half of the semester to make sure that the concepts are gelling with you okay, and that you have a basic understanding of what these concepts are. It's not really a very complex quiz at all, actually. What we can probably do is talk a little bit about it on Thursday after this particular session, unless you have access to it fairly early. So, you might conceivably could take the quiz before I even talk to you guys about filters. But I would suggest, maybe just hanging out. If you can get to the sessions, please do. And we'll talk about the content there. I wouldn't worry too much about it. If you've been following along with the content so far in the course and doing the reading assignment and looking at the video lectures, I think you'll be just fine.
On one final question, how is attendance taken? Just to make sure. Do we submit our notes from this session or are you
Yeah,
going to manually
do
put it in?
Just do that. I have the first 2 classes that we held live. I have the attendance roster that Zoom generates for me automatically. So I have those, and anybody who attended those 2 live sessions will get the credit for that. If you don't come to the live sessions, just look at the lecture videos and do the little response text blurb for each of those, and that's all you got to do. There's really no other way to calculate attendance in an online course like this other than your engagement through the LMS. So, when you do that little activity, that that satisfies that criteria. Okay. I haven't calculated your attendance grades yet. So is that probably the root of your question? Because I noticed on the grade book that it's leaving them blank for me this time. Sometimes it auto fills, like in a regular semester when I have attendance. When I take regular attendance in a face-to-face class, there's an auto-generated attendance grade that starts happening in web courses. But in an asynchronous class, it doesn't quite work that way. I'll probably calculate those attendance grades probably next week. Okay. All right. So the takeaway then from 1.4, just so that I'm clear, is I wanted you to get a sense by talking about aspect ratios that the camera can record in, by talking about recording media, and by talking about color science and the depth of the color calculations your camera is making. All of that comes to bear on how much media you need to load into the camera when you're shooting. So If you're shooting full full raster, which is the entire sensor, if you're taking an image off the entire sensor of your camera, typically in 16:9, let's say for television presentation, you can generate huge volumes of data at high bit rates or high frame rates and high resolutions. And then, of course, the size of your files will change based on the aspect ratio. So if you extract a widescreen frame out of that full raster image, for instance, it's going to change your resolution again, which will change the recording capacities of your cards accordingly. High frame rates can also affect how much media you need in your cards. And then the color science that we sometimes talk about, and the videos are talking about 8-bit and 10-bit and 12-bit color science, and that has to do with the number of colors that your camera can render based on the color profile that you choose in your camera. That can also, excuse me, sometimes have a great deal to do with the recording capacity of your data cards. So that was the point of that whole section. Some folks are sometimes confused. They ask, why are you talking about aspect ratios and you're talking about color science and you're talking about the size of my SD card? What does it all have to do with one another? It has to do with how much data your camera is creating and how much data it's trying to pack onto a card. And it has to do with the different choices that you're going to make with your cinematography in terms of how you want your audience to see the images, how saturated or accurate you want your colors to be, for instance, and then whether or not you have complexities like high-speed photography and things of that nature that affect your images. So if anybody had any difficulty with that content and you want to talk to me about it, in a side discussion, that's totally fine. I'm open to do that. I'm able to take private Zoom sessions at this point. I think I'm kind of fully up and running at this point. We'll see how long my voice holds out, but I think that's all going to be fine. So if you're okay with that section, then what I had for you guys today was just to talk about cinema lenses. So following along in web courses, talking to you about glass, we call it glass. That's the nickname that everybody kind of uses, the industry term for the lenses that we choose. And there's lots of different reasons to choose lenses. The basic need, obviously, is you need a lens of some kind on your camera to create your image. But lenses offer us fields of view, angles of view on images that we're creating. They offer us tonalities. They offer us compressions and magnification qualities and things that can be unique by brand or by format, depending on what we're doing. And I just want to talk to you basically about that, what's going on with lenses and why you might choose certain lenses over others. I'll talk to you a little bit about design, and we'll talk to you a little bit about the controls, manual controls and so forth of your lenses and how that all interrelates. Here's your video lecture that's pre-recorded. I'll put today's discussion on this page as well, probably below here, just so you have it also as a reference for any study that you might want to do towards your midterm. The videos that I've got extracted out of the presentation, which I'll show you here in a second, are all here on web courses. And then your reading assignment, downloadable PDFs from the bookshelf. These are, you're going to want to take a brief look at those. If you're checking out the FZ1000 cameras from UCF, that's the bridge camera that we had purchased for the Cinematography 1 classes. Looks like this guy here. If you're going to be checking that camera out from UCF, the instruction booklet is here for you to access. It's pretty easy. It's a simple camera to operate. It's a lot like the GH4, GH5. that some of you may have had an opportunity to work with. It just has a built-in lens, so it makes it kind of easy for you don't have to pick any supplementary lenses to go with it. Everything's sort of built in. It gives you a little indication on the top here. The equivalent focal length of the built-in lens for this camera is about 25 to 400 millimeters, so it covers a nice range. It makes it a nice camera for some of these basic assignments. So you get your instructions for that. Little chapter out of the camera assistance manual. And then I gave you anatomy of a storyboard to kind of take a look at. That'll tie in with a conversation we'll have a little bit later in the semester about framing and composition. I'm just giving it to you now so you can get a look at it, because it kind of ties in with the conversation about lenses and when would you want a strong magnifying telephoto lens, for instance, versus a wide angle lens and so forth. And it starts a conversation, hopefully, in your head about composition and framing as it relates to lenses, so that when we have that conversation further down the line, when you're choosing pieces to want to put into your assembled edit, you're already going to have made some decisions relative to those choices with the lenses that you were working with. And let's see what we got here for you. Okay, you're reading assignment out of the assistance manual. Okay, so it's all right here. Focus measurements and how to achieve follow focus on set. So that's from the point of view of the camera assistant, which I think is really, really important, because that's the kind of jobs that you guys can look for when you get out of college. You're probably not going to get hired as a cinematographer on anything coming right out of UCF, but certainly if you have good sensibilities as far as being a camera assistant, good organizational skills, and you have a keen ability to work with the follow focus apparatus and to do jobs like that on set, that'll make you highly marketable. You'll be hireable in that capacity, which is really important. That's the thing that I'm after, is helping you guys learn skills that you can use when you get out of here, that make you attractive to these companies to want to hire you in the first place. So take a look at that chapter from Dave Elkins in the assistance manual. And that'll get you going. So I want to open up the presentation here on lenses and show you what I've got here. So this is kind of a hard discussion to have as an online course, because I love when I have the face-to-face version of this class to be able to put stuff in your hand. And I can't do that today because we have this virtual disconnect. But I did. The reason I'm kind of taking the conversation from my my equipment room today is so I could have a few things around that I could just sort of put in front of the camera for you, and at least show you what I'm talking about as I sort of go through these concepts. So cinema lenses are specific for the kind of work that we do as cinematographers. So there's a carryover, right? In the beginning, when our cameras didn't shoot video, and a camera was simply for taking, photographs, there was a certain kind of a relationship that the camera had with the equipment, or the camera operator had with the equipment. So back when I was really young, and I was just a studio photographer and a camera assistant, we used manual cameras. Like, this is my OM1. This is in fact, this is early, but it's not my first one. This one's about 40 years old though. So the idea was, you're out in the field, you're taking pictures, you take a picture, you advance the frame of film, you take another picture, you advance the frame of film, and you're doing it by, you're holding the camera up to your eye, you're looking for the viewfinder, you're focusing your image, right? And then you're taking the picture, right? That was kind of the relationship, right? Now, so the equipment was manufactured ergonomically to accommodate that kind of workflow. Okay, so lenses are, have little grippy surfaces like this knurled rubber ring here to facilitate, clean, firm contact with the lens so you can do your manual focusing. You would have iris controls on the lens so that you can control the size of the opening inside of the lens as you adjust your exposure, an internal metering system, and then an advanced system that would move film through the camera. If I open this one for you, hopefully it's empty. Here's your what we call the gate, right? This is where the camera, the film goes across the gate, and as the shutter is advanced and opens and closes to allow exposure to come through, that's kind of what's happening in there, right? So a very basic ergonomic and mechanical arrangement, right? It gets really more complex when we start doing video, and then it gets even more complex when we take a camera that will shoot video and apply it to a cinematic workflow, like camera assistants and people all working around the camera, all trying to do certain things with that device, access the microphone pots for tying in microphones, for instance, changing lenses in and out, focusing the camera, operating the camera, moving the camera with the grips and everybody. It becomes a really complex deal. But this was at the center of that whole thing for the longest time, was just basically this very basic relationship, right? Like so. Okay. But you get on a film set, obviously, and you're met with a very different sort of image of what's going on. And so in this shot, we've got a young woman who's working with the Ursa Mini, for instance, and we've got an external monitor. We've got a very different kind of viewing system going on here. We got a great deal going on with the camera. We've got a pretty big lens system and this large focus assist wheel out front. This is all to make the camera more accessible to a group of people that are working with it, as opposed to just one individual, right? So we looked at the positions in the camera department early on in the semester, and we found out that we've got like at least 3 people around the camera at any given time, right? We've got an operator who is lensing the shot, right? In other words, concerned with the composition and perhaps with the movement of the camera and what's going on. We got a camera assistant who's doing nothing but keeping the image in sharp focus. And then we got another assistant who's helping that person, and they might be cataloging the shots with the slate. They might be, helping the first assistant swap lenses on and off the camera and so forth. And they don't necessarily look through the viewfinder, but they're working with other aspects of the camera and their concerns. So there's a lot going on with the cinema camera. And the biggest difference, I think, between a photographic lens and a cinema lens is going to be how well that lens integrates into the larger footprint where you got all these people grabbing at the camera at the same time, right? So, for instance, if I take the 50 millimeter lens off my little Olympus OM1, I mean, you can do 50 millimeters with a little guy like this right here, right? Doesn't take a whole lot. It's 50 millimeters is the same field of view. This lens has the same field of view that your normal eye would have, minus any peripheral vision, right? So none of the side eye is, we don't think about that when we think about 50 millimeters. It's basically what your eye sees looking forward, right? So this is a 50 millimeter lens for the Olympus OM1. Okay, and I shot a lot of film through lenses like this for a lot of different venues, clients and end uses and so forth. But it's it's designed to work on that camera as a little sort of one-man operation, right? If you want to integrate a 50 millimeter lens into a cinema camera, the first problem you're going to have is probably going to be the size. I mean, this thing is pretty small. If I show you, for instance, I probably can't even get the whole thing in frame. My Ursa Mini right here is set up with a Rokinon 35 millimeter right now. And can you imagine trying to make this little tiny lens work on this Ursa Mini? It would be an ergonomic nightmare, right? It's just not going to work, right? So the physical size of the cinema camera is going to dictate sometimes how that lens is going to have to be built, manufactured, and so forth. So I got a little, so here's a Rokinon 50 millimeter. Okay, cinema lens. And it's quite a bit bigger than my Olympus, right? And it's designed to work on a much larger cinema camera. So there's not a lot of constraint placed on this camera. It's designed just to take still images, and that's pretty much it. So it doesn't have to have extra electronics on board for monitors and for video capture and for external battery systems and everything. So the body is small, the equipment, the lenses are very small. Cinema cameras, totally different story. We need external batteries so that we can keep shooting for long, long periods during the day. We've got external monitors, so we need monitor signal connectivity. So we need a lot of connections on the camera. The camera ends up being a very large device just by default through all the electronic capability we needed to have. So sometimes the lenses ergonomically have to match the size of the platform we're working with. And that might be one, that's one reason why a cinema lens is going to be physically a lot bigger than its photographic counterpart. If you look at the zines, these are the that I used in the very first shot here. These are fairly large lenses. I don't happen to have a zine handy today. The zines are pretty big. They have a 114 millimeter front diameter. So these Rokinons have what we call 77 millimeter accessory or front diameter, and the zine lenses are about twice as wide. So they're considerably larger lenses. I'll talk to you about why that is the case in a moment. Cinema lenses tend to be constructed in smaller batches. For instance, this Olympus 50 millimeter lens that I showed you here, serial number on this guy was, where was it? Yeah, it's like 3,810,000. I mean, a lot of these lenses were made. This particular one was made in the 1980s. So the Olympus 50 millimeter lens, the Canon 50 millimeter lens, the Nikon 50 millimeter lens, very popular lenses in the 80s. There was a whole sort of wellspring of curiosity and interest in photography in that particular decade. It became accessible to regular folks. And so everybody seemed to be looking for Canon AE1s and OM10s and Nikon EMs and so forth to start shooting, and photography started becoming part of the mainstream interest. So lots of that product was out there and floating around. And as a result, when manufacturers make 1 million of something, the cost savings they can pass on to the consumer as a result of making large batches of gear like that is pretty considerable. But on the other hand, cinema lenses don't have a huge market like that until recently. The cinema lens market was fairly small and fairly boutique. So, a manufacturer making cinema lenses for movie cameras might make, only, 3 or 4 sets a year. And as a result of that, the costs of manufacturing go up enormously. So the first difference you're going to notice between a cinema lens and a photographic lens is going to be the inherent value of the equipment. And it has a lot to do with that, that manufacturing demand, whether it's a consumer demand or whether it's a very narrow professional demand that can facilitate hand fitting, for instance, of equipment, which is something that adds a great deal of expense to cinema lens products. The zines are one particular line of lenses. They are like the professional branch of Rokinon, if you want to think about it that way. The sort of prosumer end of Rokinon, the DS primes and the cinema primes that you guys have at UCF are at a much lower price point. Many more of these are made with different, sometimes different materials, not necessarily different tolerances. So the Rokinon 50 millimeter lens and the Zine 50mm lens, even though they might be physically different in size and different in price category, are going to perform fairly similar in terms of the kind of excuse me, the kind of result that they can render for you in your projects. Some of the differences in cost will have to do with some of the needs that you may have as a cinematographer. We'll talk about that here throughout the course of this. So think about the original intent of the equipment, the intent that we're going to put it through now, as far as applying it to a cinematic sort of build and footprint, I call it, on set. And we'll think about the very basic differences between cinema lenses and photographic lenses. So I have a picture here of this is a Rokinon or a Samyang. It's basically the same company. This is their 35mm lens for photographic applications. So you notice how it has sort of the rubber friction ring here for manual focus of this lens. There is an aperture control here. The aperture control controls the diaphragm inside the lens. And we'll talk about this a lot over the semester. I don't know if you can see that opening and closing or not. You see the aperture in there getting bigger and smaller as you control the size of that. Okay, so that's part of your exposure control element that the lens offers you, that capability the lens offers you. But in the process, it's controlling how much light is passing through the lens. You want manual control over that if you're working in a cinematic sort of workflow. We don't necessarily use automatic exposure control systems in professional cameras because it leaves too much creative control up to a camera that has no opinion in one way or the other on what's too bright or too dark, or too far to the left or too far to the right, or too wide or too narrow. So we like to have manual control over all of the devices so that we can make sure that our creative intent is being maximized. Okay, so we want manual control over things like iris and focus control, and so this is meant to be used by hand. So if you're a photographer and you're working alone, this is probably the way you're going to want your lens to be laid out. Now, if you're working with a focus puller and you're on a cinema camera and you've got focus assist equipment like a follow focus wheel and so forth that you can attach to the camera, you might want your 35mm to then have a little bit different ergonomic arrangement. You're still going to have your manual iris control, but now instead of a rubber manual focus ring for your fingers to grab onto, you've got a knurled pitch ring here, okay, with gears on it that are integrated into the focus ring of the lens barrel. And that's designed to marry up to the focus assist that you might put on your camera. So here's one on my Rokinon 35. You can see right here, I've got the wheel, and as I turn this wheel, it's turning the focus barrel, right? Because the drive gear is matching up to the integrated gear on the lens, and it creates a nice connection there. And so now, instead of the operator, with their eye to the viewfinder trying to focus, on their own, the operator can just think about composition and framing, especially if the dolly is moving the camera and you got a lot going on there. A lot of times the last thing you think about is whether or not the image is actually in focus. So the focus puller now has a station, if you will, built into the camera where they can work and they can control focus a lot easier with that wheel. And you can do things like mark that wheel, if you have focus markings and stuff that you want to keep track of while you're trying to keep focus of the shots and so forth. And it just makes for a lot easier way to work when you're dealing with a big unwieldy camera like this, right? So the cinema lenses then are going to be constructed with that kind of end use, that whole idea. Okay. So moving forward, yeah, here's a larger look at that Samyang if you want for a quick second here. Um, Cinema lenses are purpose built. They are designed for a certain kind of workflow. Okay, so in other words, this 50 millimeter Rokinon, for instance, because it has the, the pitch gears on there and everything, could you use this as just a regular photographic lens? Yeah, you probably could. Maybe over time it might get a little annoying to have such a sharp uh, gear ring to grab onto and focus instead of a nice comfortable rubber focus grip. You could probably do it, but this lens is designed not to be manually focused by hand like that. It's designed to be working with follow focus handle like on my Ursa Mini, or maybe something like a radio controlled follow focus unit. They call them fizz units, focus iris and zoom, to control the camera that might be on a crane, and you're doing everything by remote with a monitor and so forth, in which case you couldn't put your hand on the lens if you wanted to, because the camera might be 30 feet in the air at the end of a crane arm, right? So the cinema lenses are designed to work in that kind of environment, okay? They also will be manufactured to much higher tolerances, I think, than regular photographic lenses, as far as um, the way lenses in a system, for instance, might match color-wise and contrast-wise. For instance, you have a whole line of lenses here in the Rokinon series, let's say. You got everything from 8 millimeter fisheye to 135 millimeter telephoto. And you're going to use maybe a handful of these on a movie. And you're going to go from different sizes to different sizes based on what you want to see in your field of view when you're shooting for your edit and you're covering a scene, for instance. And when you change lenses back and forth like that within the same context, within the same scene or the same shot, um, you want to make sure that the lenses don't have a vastly different look to them. For instance, if you start your scene on a wider lens, like a 24 millimeter or a 35 millimeter to get a wide shot of a scene, and then you punch in on a 50 millimeter for a medium shot of two people approaching one another in a cafe, let's say, and then go on to longer lenses like 100s or 85s to get close-ups of the people as they talk back and forth to one another. You've gone through three different sizes of lenses now within the same series, and you want to make sure that color-wise and contrast-wise, those lenses all are very similar. Otherwise, you're going to spend a lot of time in post-production trying to match just the basic color density and saturation of those lenses from shot to shot in your edit. Photographic lenses don't necessarily take that into account, because a photographic camera, remember, was designed for snap, 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 a frame at a time, a moment in time here and there. And those moments didn't necessarily have to immediately integrate with one another. They didn't have to be, they're not part of a timeline like video clips are part of a timeline. And as you play them back, you see shot after shot after shot in sequence, and differences in color and contrast would show up immediately as, differences in the appearance of your overall image as you play that image back in real time. So cinematic lenses have to be color matched within a series. So where my 50 millimeter Olympus lens is made by Olympus, and the 85 is also made by Olympus, and the 100 and the 24, they're all made by Olympus, but they might have slight differences in color saturation, for instance, between the 85 and the 24. The 24 would be maybe more contrasty for wide angle field of view photography. The 85, which is generally associated with a lens you use to shoot close-ups and so forth, might have a softer contrast to it and maybe a little bit warmer color saturation within the same series of lenses. So photographic lenses aren't necessarily meant to match shot by shot in a sequence. They're meant to serve as a moment in time for a photographic recording, not necessarily a video recording. Okay, so, but on the other hand, in your Rokinon series, you definitely want your 24 millimeter to have the same contrast and color rendering characteristics as your 50 and your 85, because you might use all three of those lenses in the same scene for something. And you don't want to spend a lot of time simply matching the quality of one focal length to the other within the same brand or series of lenses. So motion picture lenses, cinema lenses specifically, are built to much higher tolerances in that regard. Okay, and it'll have to do with manufacturing, things like coatings and so forth, that the manufacturers pay close attention to, because cinematographers are out there demanding this kind of color matched quality to make their lives easier in post-production when you're doing color correction. Okay. Pulling focus, though, is the fundamental focus of this conversation, because that's kind of the thing that you guys are going to get to do when you get out of here. For instance, you work on a commercial, say you get a job in Orlando and you're going to work on a commercial, they'll probably fly the DP in from Los Angeles or New York. They might bring their own operator, or they might operate their own camera, right? And sometimes they'll bring their focus puller and sometimes they won't. If they don't, then they're going to have to hire that individual locally, right? And so it's good to think about the aspects of the first assistant's job and key in on those things, to make this a little bit more vocationally accessible for you in the future when you start looking for work. So pulling focus is probably going to be the job that you're going to get to do most often, hopefully, when you get out of school. And so when you're on a job like that, it's important that you ask questions like, will you be using cinema lenses or adapted photographic lenses for the job? Now, the interesting thing about photographic lenses is, yeah, they might have some quirkiness in terms of color matching, like I was just talking about, but they're also going to have some aspects, a quality to them. It might have to do with the era that they were manufactured, the era plus the brand. A lot of times certain brands of lenses are associated with certain kinds of quality aspects to an image. Are the lenses warm and soft focus, for instance, or are they sharp and contrasty and clinical? A lot of cinema lenses these days, because manufacturing has gotten so good and so precise in terms of the tolerances and the accuracy of grinding elements and the complexity of lens coatings and the sophistication of assembly that we have now. We can build a cinema lens for relatively little money that performs really, really well. These Rokinon lenses are not real expensive in the scheme of things, but the results that they render are quite good, to the point where cinema lenses can almost be too good in the quality that they offer to the user. And so there has been in recent years sort of an interest in adapting vintage lenses from older series of glass, maybe old Nikon lenses from the 70s, or I like old Nikon lenses from the 60s personally. I have a whole series of Nikkor lenses from the original 1962 manufacturing line. Big, kind of bulky, clunky old photographic lenses, but they represent the manufacturing prowess of the time, and the color contrast and sort of the color characteristics that people were looking for in optics in the 60s for magazine articles, for instance. And so given those characteristics and applying them to a modern digital cinema video file sometimes can render some really, really interesting results, which you might not be able to get, believe it or not, with a modern cinema lens without doing a lot of post-production color correction and lookup table application and stuff to get a sort of a vintage look through software application. But some of this can be done simply by choosing a vintage set of lenses that might not necessarily have been intended for cinema use, but if you can figure out how to adapt them, they can make some really wonderful creative choices. And so you have to think about how, how are you going to make this little guy work in a scenario where you have to apply a follow focus attachment and a matte box to a camera, for instance, for filters and all the other stuff going on. This is a red camera these kids are using here, and they've got it all built out around this is a Zeiss CP2. So it's a regular cinema lens, but can you imagine trying to, use this little tiny guy in the midst of this whole situation here? It might be a little bit of a problem, but there are things that can be done to mitigate some of that clumsiness. And you have to consider what the workflow is going to be, and then you have to be able to sort of justify using your, for instance, Canon 24 to 105 millimeter photo lens on your video shoot. Maybe you really like your 24 to 105. Maybe you've been shooting Canon 5D video for a while and you use your photographic lens because it's the only one you have. You're used to using it, you like it, you can predict the results from it, and you want to use it on your video camera. Well, you can make that work. Just understand that this lens is going to have some limitations, right? So in this case, we got our manual focus rubber grip ring here. Notice in the window, I got it kind of highlighted here with a yellow arrow pointing at the focus scale in here. Focus scales on cinema lenses are a little bit different than focus scales for photographic lenses. If you look at my Rokinon 50 millimeter here, here's the witness mark right here. And as I pass from infinity all the way down to minimum focus, it's a long way, right? It's a long turn, right? And that's on purpose, okay? That's to accommodate a focus puller who's trying to determine the difference between one distance and another on your focus barrel. If you look at my little 50 millimeter Olympus, to go from infinity, the witness mark is this little orange dot here, go from infinity to minimum focus. It's maybe about the same amount of rotation, but look at how tightly packed together those numbers are around that witness mark, and try to determine the difference between 10 feet and 12 feet away by moving the lens just that little bit. It's really hard to get a feel for it when you're talking about being a focus puller with a, with a secondary system like a focus assist wheel. So you might want to think about that when you're using photographic versus cinema lenses, is how much rate of barrel rotation do you have as a focus puller that will help you get a feel for the difference between distances. But in a photographic lens, you got very narrow markings, which means you have very narrow focus throw on the overall barrel of the lens. So we have to do something to this lens to, in essence, change the gear ratio of your rate of rotation, right? And what we can do is we can apply, when we use a focus assist wheel, we can apply something like a focus pitch gear to your photographic lens, and it will, all at once, it will increase the overall barrel diameter of your lens. You can see here that this is designed to fit around, this is a Red Rock Micro focus pitch gear. They come in a little bit better designs now. The Red Rocks had these big sort of lugs here that helped you fasten this onto your lens. Companies like Tilta now are making these nice rubber sort of integrated rings that you can just sort of slip on the front of your photographic lens. This is a Tokina, what is this, a 50 to 135 photographic zoom. You can see I've got a little pitch gear put on here, and it looks a lot like the rubber focus gear, and it's actually not too tough on the fingertips either. That's the newer style now that are out. You have to be very specific when you ask Tilta what size you're going to order. You got to measure the diameter of your barrel with a caliper and then tell them what size it is, and they'll send you the right size ring. But you can put stuff like this on your photographic lens to help you with the mechanical disadvantage of a lens that's this small, right? So you can imagine putting the little 50mm lens at the center of this focus gear, and it would increase the diameter of the lens accordingly, and put the pitch gear way out here, which would in essence increase the rate of rotation and give you a little bit more difference between that 10 and 12mm mark I was talking to you about here a few minutes ago, right? Where it's only maybe a 16th of a turn on the lens here as a manual adjustment. When you put that big gear on there, it might be a little bit more of a rotation on your focus wheel, which will give you more of a sense of the difference between those two spots. So if you're following somebody who's moving 2 feet in the frame, maybe forward and backward or side to side, and you're trying to follow them for that 2 feet, it's nice to have a little bit of room where you can sort of develop a rhythm and follow them and meet them mark to mark, as a focus puller. Makes a little bit more sense. So these integrated gears can be added to a vintage lens. So let's say you're plowing around an old antique shop, right? And you see in a cabinet an old lens from an old vintage photographic camera. And you might maybe pick it up for really cheap, or maybe you're on eBay and you see somebody selling an old Nikkor 50mm 1.2 for $50, let's say. And wow, to buy that lens brand new now might cost you $2,000, right? But here it is, used, inexpensive. It's 50mm 1.2 lens, meaning having a really large maximum aperture. It's going to let a lot of light into that lens. It's going to give you a lot of advantages in low light cinematography. 50mm focal length, very functional focal length, and you can get it really, really cheap because it's an old lens, right? And you'll have to do some things like putting pitch gears on here to work with your cinema camera, and then you might need to get a flange adapter, like this is a Canon EF flange that's on this lens. It's designed to go on a camera that has a Canon EF mount on it, but that doesn't mean I can't use this lens on a Black Magic camera, for instance. Now my Ursa Mini happens to have an EF flange already on it. But for instance, like my pocket camera, right? The pocket camera has a different flange on it. It's called micro four thirds because the sensor size is a little different than it is in the Ursa Mini. But I could still make that EF lens work if I got an EF to micro four thirds lens flange adapter. Okay, so you can adapt the focus ring with an integrated pitch gear. You can adapt the flange with a flange adapter from one brand or manufacturer to another. And you can take advantage of some of these deals you might find online or in, old camera shops and stuff. And, get some interesting looks for your videos using vintage glass. And that's been a really kind of a popular thing in the last maybe, I don't know, almost 10 years now. I think people have been trying to figure this whole mess out, right? Here's another form of an accessory pitch gear. This is just a rubber one. Works basically the same as the Red Rock. It's got a little lug to tighten on. You can see though that at some point, if you got this kind of thing, or even this lug on the Red Rock gear, somewhere on your lens barrel, and you're running it through that focus wheel, right, on your camera, at some point, that lug is going to become a problem because it's going to run into conflict with your drive gear here, and it's going to limit the rate of full rotation of your lens barrel. So that's kind of why I abandoned these sort of cheaper adapters, and I went with like these Tilta adapters that are made specifically for specific lens barrel sizes, because there is no lug. See, it's just one continuous seamless gear that goes all the way around the barrel, and it's rubber, so it kind of slides on, and it's got a pretty firm grip contact, so I know it's not going to come off, and it makes it a lot easier to convert a photographic lens to a cinematic application. The other thing that I would talk to you about, the difference between, say, cinema lenses or photographic lenses and or old photographic lenses and new photographic lenses, are the existence of what we call hard stops. So on this lens right here, this is a Tokina 50-135. It's manual or autofocus lens with a Canon, for a Canon EF camera, like a 5D or a 60D, for instance. And if you listen, when I hit infinity, it's got a hard stop at infinity, right? The lens doesn't continue to focus beyond that. That's in manual focus mode. But if I switch this lens, if I change the clutch on this to autofocus, now if you look at my infinity ring there, this ring can turn, but I don't get any sense of what's going on here, because the internal clutch now will be controlled by, for instance, my Canon 5D. And so an autofocus photographic lens designed to work on a Canon 5D or a Sony A7 III, for instance, it's not going to have those hard stops anymore, because if it did, it would probably burn out the focus motor, the autofocus motor in a Canon 5D really quickly. And that would be a problem for, you know, someone who just bought a $3,500 camera body to have it burned out like that. So there's no hard stops in autofocus lenses for photographic cameras. As a result, you know, that's a problem for us as cinematographers, because we don't ever know where infinity is and where our minimum focus of our lenses are. So cinema lenses, old photographic lenses have hard stops, and cinema lenses will have hard stops, so that you know, we know by simply by feel alone, if necessary, where, you know, minimum and maximum are on the lens barrel. And we know once we hit that hard stop that we're at the end of the focus rotation, and we're either all the way out at infinity or all the way to minimum focus. Okay, so hard stops are really important for cinema lenses, especially if you're a focus puller. Okay, some focus assists, like this one, for instance, on my Ursa Mini, I've taken them off, but I can add little lockdown screws to this to limit the rate of rotation of my focus handle to minimum and maximums. You just you know, you pick a spot where you want to stop rotation, and then you rotate that lug to the top and lock it, tighten it down. And then when you focus the other way, you pick that other maximum, maybe it's infinity, and then lock that down. And I can impose hard stops on a lens without hard stops through my focus assist. But I kind of don't like messing with that stuff anymore. I would just rather go to a system of lenses that have the focus gears, hard stops, and everything integrated in them already. I've kind of gone past my tinkering stage at this point. I used to really enjoy fiddling with different kinds of vintage lenses and making them work on these modern cinema cameras, just to see how it would be done if somebody wanted to do it. But it gets too fiddly after a while. And if I know that I have a system of lenses that are already designed to do what I want to do, I'd much rather go right to that source of equipment and use the specific tool, the right tool for the right job at this point. It would only be a situation where, for instance, if I wanted to pull out those old Nicors I was telling you about and use those for a commercial or something, let's say, then the advantage of those lenses becomes an aesthetic visual one. And then I will tolerate the little idiosyncrasies of those lenses in order to get the visual results I want from them. But if I'm not looking for that specific visual result from those lenses, then I probably won't choose those Nikkor lenses to work with under normal circumstances, because they're not ideally suited for focus pullers and all of the apparatus that we're going to use for the cinema camera. Okay. Um, there are other aspects of cinema lenses. Focus breathing is something that it's kind of hard to discuss, but I think, is this video? No. Oh, yes, it is. Photographic lenses, since they're not designed to work with video necessarily, they don't have control over their defocus characteristics of the image, right? So if you look at this this shot of the Film Riot mug, he's going to focus in the foreground. He's going to throw focus to the background, and notice how images that become out of focus will also change size. And that's what we call focus breathing. In other words, if you throw focus to a different object in the frame and something in the foreground that was sharp is now out of focus, does it get sort of big and blobby as a result of that? That can be a distracting characteristic in a lens. Let's see how well this video illustrates that. Yeah, so you see how the mug seems to like change size, whether it's in focus or out of focus. That's the kind of thing that can sometimes be considered distracting if you're doing a real sensitive focus throw, for instance, in a conversation between two people, and the subject matter is very delicate and the moment is very tense, right? The last thing you want to do is have the lenses demonstrate um, a characteristic that is sort of calling attention to itself and taking your audience out of that moment, right? So cinema lenses are designed to have a minimal amount of focus breathing as well between objects that are in focus and out of focus in the foreground versus the background. And that's because the manufacturers of cinema lenses know that part of our exhibition process is to have shots where we might delicately throw the focus from one aspect of the frame to the other in the midst of a line of delicate dialogue or something. And we don't want anything to distract the audience from that moment, because there's an important message that's being parlayed there. And if they stop thinking about your story and start thinking about how badly the lens is performing visually, it takes them out of that moment. It's called the suspension of disbelief. And then it kind of ruins the moment for the audience, and sort of then we have to regain their attention and re-immerse them in our story somehow. So we don't want the flaws or the shortcomings of our equipment at any point um, to interfere with that very important interpersonal communication that's happening between the filmmaker and the audience, right? That's all I'll really say about focus breathing. There's no need to to hover on it any more than that, I don't think. You will hear folks discuss the difference between t-stop values and f-stop values. We'll talk about t-stops and f-stops when we talk about exposure after your midterm quiz. But basically, the apparatus inside your lens that is changing size, the aperture, the diaphragm inside there, okay, it can be regarded in two different ways. Now, what it's doing is it's controlling the amount of light coming through the lens, okay? And you're using that function to adjust, among other things, basically the overall brightness of the image, whether it's too bright or not bright enough. Let more light through or block some light from passing through. But in terms of the relationship of that function to the camera and the shutter, and then the overall brightness of the image, has to do with exposure calculation. And like I said, we'll talk about next week or the week after maybe. But the stop value that is represented on the lens by these markings here refers to the size of the opening that lens is managing for you while you're controlling your exposure. So a large lens opening at the low end of the number scale is going to, refer to a large diaphragm opening, which is going to let a lot of light through the lens at one particular time. And then as you close that iris down, you'll notice you're also closing the number scale down to a much smaller number, okay? And we can use those numbers in calculations to create exposure control. And you can either think about it in terms of a formulaic calculation or a literal transmission calculation. So these numbers, we refer to these numbers on the side of the lens as f-stops, right? Or t-stops. And depending on whether it's an f-stop or a t-stop depends on whether or not it has been merely calculated the focal length, the overall focal length of this lens. And this is why I give you this sort of interesting mechanical drawing here. The focal length of this lens, and then the relationship of this focal distance and the size of the aperture that is chosen gives you a calculation that results in one of these numbers, right? If you run it through a formula, okay? And so F, formulaic calculation for these numbers, is what we refer to when we talk about f-stops. T-stops, on the other hand, say, okay, we understand that there's a focal length versus diaphragm relationship, okay, that can be derived through a formula and give you a set of numbers. But what about the density of the glass? Okay. Light passing through a lot of layers of glass, like you see in this mechanical drawing on the screen here, can offer, in all intents and purposes, an imperative to light passing through that lens, right? It can slow it down. I mean, it's in the realm of the very small in terms of the calculations, but nevertheless, if there was no lenses in the barrel at all, light would pass very easily through the barrel, right? But when you stack a bunch of glass in there, it's going to be harder for the light to get through all that glass and get through the barrel completely. And there is a difference in the calculation when you consider the density of the glass in a 50 millimeter. So for instance, my little Olympus 50 millimeter lens, there might be, say, 5 elements of glass in here, right? But my Rokinon, if anything else, the glass is a lot bigger and probably a lot thicker, right? And in some cases, there might be more elements of glass in this Rokinon cinema lens than there are in this photographic 50 millimeter lens because of the way this lens has to perform, right? So that means an f-stop on my Olympus 50 millimeter lens compared to the similar setting on my Rokinon cinema lens. If you were to look at the images side by side as a projection, you might see that one looks maybe a little darker than the other. And it might be that the cinema lens's f-stop looks a little darker because there's more glass the light is going through, and it's drinking up some of that available light through the projection. So a t-stop then is a set of numbers very similar to f-stop numbers. They look almost identical, but they consider the density of the glass inside the lens as well as the mirror calculation of f-stop, focal length to diaphragm measurement. Okay. And that's all you really need to understand for now about the difference between t-stops and f-stops. One is a transmission value, T for transmission, and one is a formulaic value, F for formula. Okay. One of them is the reality of what light does as it passes through your lens, and the other is a mathematical assumption or calculation of what happens as light passes through your lens. Okay. Cinema lenses are manufactured with t-stops so that, again, the same reason you would pick a series of lenses for a cinema shoot, like say the Rokinons, because they all have the same color and contrast rendering characteristics. They'll all be also calculated for t-stops. So if I was using a set of vintage Nikkor lenses and I just did a shot on my 35 millimeter lens at an f2.8, and then I put my 50 millimeter Nikkor lens on for a close-up, and I set the lens to f2.8, the shots in terms of brightness probably won't match, because those lenses haven't been designed to work together like that, one to the next seamlessly. On the other hand, if you calculate your lenses with T-stops and the lenses are calibrated based on the density of the glass, if I'm working with Rokinons and I just did a shot on a 35 and I go to my 50, the 2.8 on the 50 millimeter has the same brightness and contrast rendering as the 2.8 on the 35 millimeter lens, because they're T-stop calibrated instead of f-stop calibrated. Okay, so it's a finer way of controlling the quality of your overall image when you're using cinema lenses that are calibrated with T-stop values. Okay. And you can get a sense of that from the videos. Okay, Matt Granger does this little video here. You guys can watch it through web courses on your own if you want. And he'll do his best to discuss with you the difference between the two values as well, and give you a little bit of video illustration to boot. Okay. Yeah, this is just the formula for focal length and f-stop value calculation. And this is your T-stop formula. Okay, you don't have to know all this. I would never ask you to do this on a quiz. That would be cruel and unusual punishment. I just want you to see that there are actual, ways of deriving these values. The biggest reason we want to know this information is like when we're lighting on set, for instance, I have to put those values in my light meter, right? So if I turn my light meter on, what's going to happen is the meter is going to want to know, for instance, I'm going to take a light meter reading of my key light here, for instance, right? And it tells me, you see that? A 4 4/10, right? So that corresponds to the number on my lens, right? So that's another reason why I want, manual control over that, because I'm going to decide, when I'm doing my lighting, I'm going to decide what kind of f-stop value I want this light source to possess, right? And it's going to have to do with how it's rendering on my face and the quality and the contrast and all of that stuff. It's a bigger conversation that will evolve over the course of the semester, right? But essentially, it starts with this. It starts right here. It starts with me needing to know a number to dial into my lens on my cinema camera, right? So I want this sort of system to be calibrated and as precise as I can get it, so that as I'm figuring these things out, as I'm deciding what I need from my light sources, and my meter is telling me how much is coming out, when I dial that into my lens, I need to know that that information is going to be accurate and that it's going to look the way it's supposed to look on the monitor after the fact. Okay, so that I can control mood and tone visually with my lighting now, using my lenses as my control tool, using my light meter as my accountability, or as my way of verifying my results. And this is part of this thing that's starting to go on here with the cinematography now. It's kind of a whole process. Okay. Also think about lenses as they're little projectors, right? I like this graphic for that reason. This lens is designed, to take light from the scene, pass it through here, through the f-stop, and then strike your image sensor, and then your image sensor is going to interpret that information and help you create your image files, right? So think of it as a little projector. Think about, the light that's passing through this thing when you're using it, and how you're controlling that light by controlling the size of your diaphragm, and then how much light is coming through. Well, some of it has to do with what might be available to you. Some of it might have to do with, for instance, how much am I providing myself in this situation, right? I have an LED source over here, and I'm just whacking it into the wall, right? Bouncing it off the wall onto me to create kind of a, a nice key light, right? And then it's coming down to tools like this, how we control the overall image, right? I think I kind of talked to you about the difference in lens flanges and stuff. So there's EF mount is very popular if you're a Canon user and you're using EOS cameras, for instance, or even their E-series cinema cameras have EF mounts on them now. So you can take your like your Canon 24 to 105 from your 5D kit in your camera bag, and you can throw it on your EOS C300 if you want and use it. Nikon was kind of running neck and neck for a while, but they've sort of fallen behind in the video digital video realm of things, and they've sort of retreated back to their photographic roots for a while, and they're focusing more on creating really good photographic still cameras, which is fine. There's plenty of cinema camera competition out there right now. Sony is, running neck and neck with Canon right now in terms of mirrorless camera bodies, and their now Z series of cameras. The Z, what is it? The 5, the 7, the 9 cinema cameras, and then the A7 IIIs and so forth. All different manufacturers. Usually they have their own proprietary lens mounts. Blackmagic is one of the few camera companies that's out there that they don't make lenses or anything. They make cameras and post-production hardware and software. So when they build a camera, they'll put a lens mount on there that they think is going to appeal to the broadest number of clients. So their Pocket 4K, for instance, came with a micro 4/3 lens flange. That's the same lens flange that's going on, for instance, the Panasonic GH5. Okay, so the GH5 has the same lens mount as the Pocket 4K. When Blackmagic, when it came time for Blackmagic to make a Pocket 6K, they started asking, who's going to want a Pocket 6K that doesn't already have a Pocket 4K? And the answer was anybody that was going to be shooting high resolution stuff. And so they thought, well, high resolution in a small sensor is important, but high resolution in a larger sensor might match nicely with, for instance, their Ursa Mini, which has a much larger sensor in it than the sensor in the Pocket 4K or the GH5 for that matter. So they put a larger sensor in the Pocket 6K, and then therefore could put a lens flange on that would accommodate a larger image sensor, the Canon EF lens mount. If you think about these lenses again as projectors, think about an image cone coming out of the back of this lens. What size image sensor is it going to be able to cover at a given flange focal depth, right? Which is generally, under 1.5 inches. Okay. So a small image sensor like a micro 4/3 and a GH5 will, utilize a lens that has a much different projection coming out the back, a much smaller lens, for instance. This is an equivalent, by the way, on the GH5 of maybe what this would be on the Ursa Mini, right? Because this is designed to cover a smaller image sensor than this one. Okay. Different lens flanges for different manufacturers. They can be sometimes integrated back and forth with the use of adapters. Adapters can get very kind of clumsy though. And every time you add an adapter to a situation instead of a native relationship between say a camera and a lens, you're allowing for a possible problem with quality control or with electronic control sometimes. Sometimes when you use lens adapters with Canon EF lenses on micro 4/3 cameras, for instance, you may lose the electronic control over that lens, the autofocus control or the iris control. if the lens doesn't have an external iris control ring, right? If it's all internal for a photographic aspect, you can lose that control sometimes by adapting lenses to flanges other than the one they're designed to work with. So be careful if you're going to do that. Everything is possible. You can do virtually anything these days. Just understand that there might be some limitations when you adapt something to a system that it wasn't intended to work with. You'll have to work around some limitations. Okay. Automated lens mounts, you'll be able to notice them right away. You'll see like this is a Canon automated lens mount. It has these brass contacts on there. This is a Nikon automated lens mount, and it has these contacts here. The contacts correspond with contacts on the lens flange on the camera itself. And that's so that the camera can control things like the aperture size of the lens automatically through the camera system. Like this Tokina, for instance, with the Canon EF lens mount on it, you'll see it's got the brass contacts for control by a Canon 5D, for instance. And notice that there's no aperture control ring on this lens, right? It's done internally and electronically by the camera controlling and telling. You'll push a button on the camera control panel that will then allow the camera to adjust the iris inside this lens. Now that's okay if you're a one-person operator working alone, right? But if you have a camera assistant that's trying to set your exposure control for you, and your operator is just operating and you're the DP sitting in a chair next to the director, we need manual control over that system. So that's why cinema lenses will have these manual iris controls. And you'll notice on the barrel, on the flange of this Rokinon lens, there's no contacts here, are there? There's no contacts because this lens is not designed to communicate electronically with any specific camera. Okay, it's designed to work independently of the camera. It'll mount on anything with a Canon EF flange, right? But it's not going to communicate any information, and it's not going to allow the camera to control it in any way. It's going to have to become the purview of the camera system to make sure that aperture is set correctly based on what the DP or the gaffer discovers by metering their lighting. Make sure that that's set properly, in addition to making sure they follow focus correctly while the scene is unfolding and the subject is moving through the frame. Okay. I think that's all I want to get into as far as lenses here. I'm talking here about the best lens to use is the one that is suited for the purpose, the specific purpose that you have at hand. So try to match your tool set to your objectives, right? And try to do as little adaptation as possible to make your life easier when it comes time to working. Because if you're working professionally, a lot of times you're working under pressure. Okay. And so when you're working under pressure, the last thing you want to do is have a lot of little details that you have to remember in order to make a non-specialized piece of gear work in a specialized situation, right? So if you're going to do something like that, prepare adequately in advance, adapt everything that you can possibly adapt, understand how that piece of gear is going to work in the situation you're going to put it in. And then it has to be worth it, right? It has to be worth all of the time and trouble that you're going to invest to make it work for the situation. Otherwise, the best thing for you to do in a professional situation is to seek out the gear that's designed to work specifically the way your client is going to ask you to work. If you're going to be working on cranes with focus assistance and so forth, and you're going to do a lot of remote monitoring, and you're going to be moving very fast and doing a lot of shots in the course of the day, the last thing you want to do is have a lot of little bits and bobs you got to keep track of in order to make a non-standard piece of gear work in a standard situation. So seek out cinema lenses in those situations, fully integrated cinema cameras in those situations as well, and pick the most qualified gear that your budget can afford or that you have accessible to you. And then and only then, if you have to start compromising, start horse trading, um, what you need to do with the gear that you have available to access and understand the limitations and figure out, the best combinations of gear at that point in time. Okay. You're going to have a shooting assignment that'll come due probably the week after next, I think it is. It's going to ask you to simulate some shots. I've given you these storyboards to look at so you can get a sense of, what we call a wide shot, what we call a full shot. Full shot is head to toe of a subject in a frame. A wide shot is something we might use as an establishing shot, for instance. And then things like medium shots. This is a little tight for a medium as far as I'm concerned. A medium shot, I think, is from the belt buckle to the hairline. Here's a close up. Here's an extreme close up. Here's a big close up, right? You're going to be asked to do a series of shots. It's 4 or 5 shots, I think, in a shooting assignment, and just sort of simulate these compositions with your own subject matter. Now, it's not ideal for you to use stuffed animals and to use toys. Pick a human subject. It's far easier to work with. It's far easier to understand the relationships, framing, and so forth with full scale subjects versus really small subjects. Very rarely do I find that a student is successful in using a toy or a stuffed animal to demonstrate some of the things that I ask you to do in these shooting assignments. So if at all possible, use human subjects for all of this stuff. And remember, every time you have a shooting assignment, it should be an opportunity for you to not just explore the concepts that we're talking about in class, but also to generate some content that you might want to show somebody at some point in the future that might speak towards your ability if you're looking for a job, right? So the last thing you want to do is go into a job interview where you're going to show somebody a video reel of your cinematography prowess, and it's shots of your stuffed animal on the bed in your dorm room. Okay, that's not going to impress a professional client. So take the opportunity to do the best possible quality job you can do on these homework assignments. It's not just for me. It's not just to impress me. It's to give you some content that you can show clients later that demonstrate what you're learning, how your skill sets are evolving, right? And think about it as a little bit of a calling card. You're going to put a reel together at some point before you get out of UCF, and you're going to want to have that work demonstrate the best of your ability, right? And so you want that content to be something you wouldn't be embarrassed to show a professional client who is possibly looking to hire you for a job. Okay, so use human subjects. Do a little bit of staging, put a little effort into it. In that regard, it'll pay dividends in the long run. I promise you. Okay. So check out that homework assignment. It'll be in web courses. Check out your reading assignment, the downloadable PDFs, and then of course the embedded videos. Okay. And that's the lens discussion for this afternoon. It's a fairly broad conversation, I know. Understand that whatever we're talking about today, aspects of this conversation will probably carry forward in other conversations throughout the course of the remainder of the semester. So consider this the start of a conversation where you're considering lenses as part of your creative control. Okay. Does anybody have any thoughts or questions about this content, the way I presented it to you today? Everything more or less make sense? If you look over the content a little bit more, look over what I've put. Thanks for the thumbs up. Look over the content a little bit more on web courses. Check out the reading on from Elkin's book. A lot of times these themes seem sort of different or disparate in some way, but it'll all tie in. I promise. When you start thinking about lenses from the point of view of a focus puller, it's going to start to make sense. Discussions about barrel rotation and integrated gears and so forth and so on. So check that out. I also want to encourage you, even though this is an asynchronous class and it's online, there are still people at the equipment room at UCF on campus, and they are there pretty much 5 days a week. If at any point, for instance, I didn't have a Zine lens to show you today, if you wanted to look at a Zine lens, you could go in, pay a visit to room 157 down there at UCF at the Nicholson building, and ask somebody to pull a set of Zine lenses and let you take a look at them. You can put them on a camera and you can, set them up on a tripod, maybe go on the stage and just look through the lenses and see, see what they do, see how they feel in your hand. This doesn't have to be a disconnected relationship here. You can go to the campus and you can look at this stuff physically in your hand if you want to, if that helps you in any way to absorb any of these concepts. Just go to 157, ask the folks that are working down there if you can take a look at some of that gear. If they're not busy, I'm sure they'll be happy to pull it out and let you take a look at it. Okay. That's it then. That's all I have for you today. So does anyone have any questions about anything at this point moving forward before I adjourn? No? So shall we call it a day then? I will meet with you guys. Thank you. I will meet with you guys on Thursday. As long as this is going okay and you can understand me all right, and my voice seems to have held out at least for an hour and a half, so that's a good sign. Then we'll move forward with our live sessions again, and you can come to these or you can just watch the recorded videos. You don't have to do both. It's up to you. Okay, but don't forget to do the little text blurb. If you don't come to the live session, do the little text response so you get credit for the attendance. Okay. All right then. I'll ask for a motion to adjourn. Anyone? And a second on the motion to adjourn. Anybody? You guys ready to go home? Ready to call it a day? All right then. Thanks very much. I appreciate your time and attention. And if you have any questions for me, if anything occurs to you after the fact, shoot me an email and I'll communicate to you through WebCourse's email that way. Otherwise, I'll see you guys same time Thursday. All right, 2 p.m. Thursday. All right. Thanks so much. Appreciate it. Have a good afternoon. And I'll see you in a couple days.